In this video, we're going to go through elimination technique, substitution technique, and graphing technique examples. So I would highly recommend, if you feel comfortable, pause the video, try the problem yourself, then watch through to make sure you got it right. Okay, here we go. Elimination technique. The idea is take your equations, make sure that they are lined up with the like variables vertically above each other. And in this case, they are, because I have my x terms above my x's, my y's above my y's, my constant terms above my constant terms. And my equal signs are lined up, all looks good. So then what we're going to do is multiply one or both equations by a value that will make my values opposite. So that way when I add them together, it makes 0. So the easiest, the most simple one looks like it's the x's, where I want to multiply this bottom equation by -3. So if I multiply by -3 to both equations, that's going to give us 3x minus 4y equals 12 over the other equation, which would be -3x minus 18y equals -15. So then the elimination technique says next we add, and I highly recommend add, because when we get later in the course, the methods we're going to use always come out easier if you add the equations. So even though you could technically subtract, please don't. Practice adding. So 3x minus 3x, that makes 0. Then looks like a 6. 0. Now, a -18 and a -4, that makes a -22. Y. And then -15 plus 12, that makes -3. So therefore, my solution for y, my value for y, is 3/22. All right, another nice, beautiful number, right, guys? All right, so now we've got that all worked out. So we say, now I need to take this y value, substitute it back in to figure out what x is. And I would pick whichever equation looks easier. They both look pretty bad, so I'll just use this bottom one. So everywhere I have a y, I'm going to replace it with 3/22. So that's going to leave me with x equals, sorry, not equals. That's going to leave me with x plus 6 times 3/22 equals 5. Now remember your algebra techniques. I can divide here. I can at least say 2 goes into 6 3 times, and 2 goes into 22 11 times. So that's going to give me x plus 9/11 equals 5. So then when I subtract the 9/11 over to the other side, that'll give me x equals 55/11 minus 9/11, which simplifies to make, 55 take away 9, that would be 46/11. So the solution to this problem is an ordered pair, because we remember from the theory that the solution was where the two lines intersected. They intersect at the value of 46/11, 3/22. There's our solution. Fantastic. All right, that is elimination technique. Moving on to substitution technique. Now, substitution, notice it's the same problem, right? So we should get the same answer, hopefully, as long as I didn't make a mistake. So substitution says pick either equation, solve for a variable. Whichever variable seems easiest, or when you substitute it will be the easiest. So you kind of look ahead. I'm just going to solve for this x, because it's really easy to solve for. That would give me x equals 5 minus 6y. So now, everywhere I have an x, I'm going to substitute that back in and replace it with 5 minus 6y. But remember, it has to go back into the other equation. You have to substitute it into the other one. If you substitute it back into itself, then you have avoided the other equation, and you will not get the right answer. You're not going to find where the two lines intersect. You're going to find where the one line intersects with itself. Okay, so this is going to leave us with 3 times 5 minus 6y minus 4y equals 12. Okay, now I will go ahead and distribute, and that will result in 15 minus 18y minus 4y equals 12. Combine like terms, which will give us 15. Let's see, -18 and -4, that makes -22y, which is equal to 12. Next, why don't we subtract the 15 across? So that'll give us -22y equals -3. Last but not least, y is equal to 3/22. That seems familiar. That seems familiar. Hey, there it is, right? 3/22. So I'm not going to bother taking that value and substituting it back in for x, because I already know it's going to be 46/11. So therefore, I'm going to say it's 46/11, 320 seconds. But if you needed to, the one nice thing, if you hadn't already done the problem another way, notice we've already solved for x. So you would take this 320 seconds, substitute it into there, and there you go. Okay, substitution technique. Big idea, recap, solve for a variable, substitute it back into the other equation, and solve. Okay, we're going to solve this last one using graphing. And the idea here is we're just going to graph it. We're going to look at the graph and see what it looks like. So for now, you could technically graph any which way you want, but I would highly recommend practicing a method that you may not have gotten a lot of practice in previous classes. It's called the intercept method. Okay, and the reason I like this is what we're just going to say is I know an x and a y intercept are found by substituting in 0 for the other variable. So, for example, a y-intercept comes from letting x equal 0, and an x-intercept comes from letting y equal 0. So if I was going to graph this first equation using intercept method, the first intercept I would just find by plugging in 0. So that would give me what? Negative 4y equals 12 because the x was 0. So therefore y equals negative 3. So therefore I have an intercept at 0, negative 3. I find the other value by substituting in 0 for y. So that gives me 3x equals 12. So therefore x equals 4. So therefore I have the intercept at 4, 0. So now, how many points do you need to graph a line? Just 2, right? I'll do this one in green. I'll call it letter A. So therefore I have it at 0, negative 3 is one of my intercepts. The other intercept is at 4, 0. So when I connect the dots, pardon me, drawing on a computer screen is always a little difficult to draw lines. Okay, there we go. There's that graph. And I will label it with A. Now, for B, for the other equation, how are we going to graph that? Why don't we do y-intercept, slope-intercept form, just because we can. All right, so we're starting with x plus 6y equals 5. So therefore, 6y equals 5 minus x. Or if you want it in the kind of standard form, we'll do as negative x plus 5. Now I'm going to divide by 6. So that's going to be negative 1/6 x plus 5/6. So how do I graph this? Well, I go to the y-intercept of 5/6, which is just under 1. Right, just under 1. And I put my y-intercept there. And then the slope is saying I'm going to go down 1 and right 6. Right? So I need to have 6 little dashes. 1, 2, 3, 4, 5, 6. All right, so my next point will be down 1, right 6. 1, 2, 3, 4, 5, 6. Somewhere right about there. And there's my other line. So the solution to this problem should be somewhere right around there. Now, how good is this solution? Well, it's kind of terrible because I didn't use a perfect graph and I just kind of free-handed. But the idea is, do we get an idea of about where the solution should be? And do we get the idea that there is exactly one solution? Because these are both linear equations and they are only going to intersect at one place. So this is the big thing I want from graphing. Do not solve any problems by graphing. Yes, you could use your calculator and have it spit out answers. Don't, because in the future, you're not going to be able to use your calculator in the way that you're used to. I'm going to show you some new techniques, but you can't just use the graph, do the intersect. You won't be able to do that, so don't practice that. It's a useless skill in this class for the most part. We'll do it every once in a while, but yeah, not for now. All right, so we practiced our 3 methods: elimination technique, substitution technique, and graphing. Why do we have these 3 different methods? Well, for different situations, right? The big idea is you want to pick the easiest method for that particular situation. No one method is used for everything. It's like killing an ant with a sledgehammer. Okay, you always want to pick the easiest method for any particular scenario. And as we learn some new methods, I will kind of point out when one is easier than another. But for now, just kind of practice all 3 and understand we're never going to do graphing. Just practice it for your visualization, but we're never going to do graphing. Okay. All right, we'll see you in the next video.